So we're going to be talking about substreams on Antelope. We're using a technology called Substream. It's been developed by String Fast team, and it's under the umbrella of the Graph. And it's a high throughput blockchain extraction tool. So the tools of what it does is that it extracts, transforms, and load. Typical data processing where if you have data, you need to get it out of a database, and you need to either manipulate it, transform it, and then you need to load it into whatever medium that you want. It could be a CSV file, it could be a database, it could be a SQL database. So that's usually like the three main core pillars is extract, transform, and load. And that's what Substreams can do. And I'm going to explain all the tooling around it and how it gets across. So I can start. So for the streaming data, it uses gRPC, and it also connects to Connect Web, which is a sort of a proxy for gRPC. gRPC is built by Google, so it's really reliable. And it's also language agnostic, which means that when you're communicating with gRPC, you can use Python, Node.js, Go, Rust, pick your language, and most likely there's going to be gRPC support. So you can stream in any language. Most of the team, we use Node.js, but the Streaming Fast team builds everything in Go, and we also have a tool in Python. So you can see that it doesn't really matter what language you're building this with. You can pick your language, and there'll probably be support for it. And when you're coming to extracting data, that's where the Substream, kind of like a smart contract, you would build code to extract the blockchain data that you want, like building an index. That's using Rust. So all of the extraction tools are using Rust. So there's a little bit of learning curve learning Rust. But if anybody's built smart contracts on EOS and you got to learn C++, that's also a learning curve as well. The type of data that you would extract is block data. So the whole block, that's the first primitive data set that you're going to get from Substream. It's the block information. And that's like the block number, the clock, all the Merkle roots. You have actions, transactions. You have state changes. So whenever there's an action that impacts a table on the smart contract, it will show you the difference. So the before and after values. For example, when you're doing a token transfer, you're going to user A transfers to user B, -1 + 1. And that would be a state change. And that in Substream is capturing all of those state changes. Whether you want to keep the before and after or only care about the after, or maybe you only care about the delta, right? The in between, what is the changes? You have access to that type of information. And you also have access to what time it happened, at which block number that all these events happened. This, you can store all the information or you can ignore it. It really depends on your use case, but you have access to all of those primitive data sets, action, events, dates, and all the block meta information. And the other thing too is after that, you've got the data that you care about. You might want to filter it because you don't want everything. You don't want the whole block with every single transaction. And this is where you get into filtering. You can filter by, let's say, account, or you can filter by a token symbol. You can say, I only want EOS tokens, or I only want the account that's my account for whatever, or my smart contract. You can filter and only fetch the information that you want to get. You can also put parameters. So maybe you don't know what you want to look for, but you want to put a parameter that says, if from equals, I'm going to tell you later, which is like an input parameter. You can also provide that, which makes the extraction and the sort of filtering very flexible, because you could put a parameter that in the future, you will tell it what the account name is down the road. So you can filter it. So there's the filtering. And once it's all filtered and extracted and transformed to your liking, then you need to load it into your database of choice, let's say. So that is what we call sinks. So it'll be like Substream sinks. They're usually programmed in either Node.js or in Go. So those will be the two languages. So you don't have to use Rust anymore. You can either just skip to I already have my data. I just need to load it into my Postgres or SQL. And that's where you get to see the data for the first time, because you've extracted it. Now you're loading it into, perhaps it's a CSV, or perhaps it's a web server that you're just posting data to, a webhook. Or maybe it's Google Sheet, or you want to load up your Google Sheet. So a Google Sheet is like a database. Might not be the most elaborate database, but it's a database. So if you're using also Postgres, MySQL, Elasticsearch, all of that, you can then load the data that you extracted from Substreams into your data source. So that kind of sums up all the mechanics. And you can see with that type of a flexibility, with sort of an extract, transform, and load, let's say, rebuild public API endpoints, such as the Atomic API. So you can rebuild some of these on-chain APIs using all of these mechanics. The two big things that most all blockchains use or depend on: tokens and NFTs. That's, let's say, the 95% of the use cases. Everything that is DeFi kind of revolves around tokens, whether it's the assets that you swap, whether it's the LP tokens that you receive by providing liquidity. So everything kind of revolves around tokens for the most part. What we're aiming for is to go and build a token API that would be leveraging Substreams. That would be the go-to standard example that people can grab to get started. That way, it's simple mechanics. You have simple things like issue, transfer, all of the sort of token mechanics that you would expect. And then you have an example that you can then build on top of that. Maybe you have this very specific use case. You have a game or you have a marketplace, and then you can just modify the token Substream API example with your own. And we're also going to be doing one with NFTs as well, starting with Atomic Assets. Atomic Assets is a lot more complicated than the standard EOSIO token. So there's like collections, schemas, templates, but it's all data that is a table or an action. And we're also going to be looking into doing the same for EV chains as well. So we were going to have ERC20 and ERC721. So that way you have something to compare with an EVM environment, but using the same stack. That way, regardless if you're on Antelope or regardless if you're on EVM, it's the same stack and it's the same mechanics using Substreams. And that's what we want to bridge. We want to bridge that it's multi-chain and multi-platform, multi-ecosystem. Essentially, it's if you want to be able to use Substream, you can be on EVM or Antelope or any other supported chain that has Substreams on.